can answer questions A and B quite quickly if you take the time to organize those numbers. I would organize them in a table. So we're starting with blood samples, 500 of them that are known to contain HIV. So we have blood samples that we know have HIV. So of those, the ELISA is positive for 489 of those samples, which means that it's negative for the other 11 samples. So that's for a total of 500. So I'm going to cross these off as I use them, so I know I've used them all. So the ELISA is applied then to 500 other blood samples that are known not to contain HIV. So no HIV. So of those samples, 37 of the results are positive. I'll put that here. So then 463 of those samples are negative, and that's out of a total of 500. So notice we can finish this table here. So the 489 plus 39, or rather 489 plus 37, that should be 526. So here, 463 plus 11 would be 474. So either way, whether you add the 526 and the 474 or the 500 and the 500, you get a total of 1,000 in the entire table. And all I've done is just use that table as an organization tool. So to estimate the probability that we get a positive test result under the condition that it's applied to a blood sample that does not contain HIV. So we want the probability of a positive test result given that it's applied to a blood sample that does not contain HIV. So we want to look at the no HIV column. So in that column, the likelihood of a positive test is 37 out of 500. There you go. If you want to write it as a decimal, you certainly can. You don't need to. 37 divided by 500. That will give you 0.074. So there we go. So we can use that same table to answer the next question. So here, positive test results, what proportion actually contained HIV? So I'm interested in the probability which proportion contained HIV, given that we saw a positive test result. So under the condition, provided that we saw positive test results, what proportion actually contained HIV? Well, now we are locating the positive row. So the ones that actually contained HIV, that would be 489. Out of the total number of positive test results, that was 526. So the fraction is very important. 49 divided by 526. I don't remember what that is. There we go. We'll call it 0.930 approximately. So by far and away, those two pieces of the question are the most important parts of the question.